for the rest of the videos or examples for 4.2. You're watching this only if you feel that you need additional examples to go over. So on this one here, y equals 3 cosine of 4x plus pi. So we're going to start with our a value equals 3. Our b value equals 4. So our period would be 2 pi over 4, or pi over 2 if you reduce, which is 90 degrees. So our length of our graph is going to be extremely, extremely short on this one. C value, we don't have a C value, it's 0. And D, remember we have to take this and divide it by the B value, so we get pi over 4. But don't be confused, this is a plus sign, which means I have to do a double negative to make this one negative. Or 45 degrees. So not only are we squishing this thing into 90 degrees, we're also going to move it to the left 45 degrees. So to get our phase shift, to identify our beginning and end point, we do 0 is less than or equal to 4x plus pi, which is 180. Do this in degrees just for you. Less than or equal to 360. I subtract 180, subtract 180, subtract 180. We get negative 180 is less than or equal to 4x, which is less than or equal to positive 180. Divide each piece by 4. And we get negative 45 is less than or equal to x, which is less than or equal to 45. So we're going from negative pi over 4 to positive pi over 4. So 0, we're going to put negative pi over 4 here. Same length, positive pi over 4 here. And our 0 is our middle point, and then we need quarter points. Okay, it's going to be a very small squishy graph. So A times the pattern. So you have 3 times the cosine pattern, 1, 0, negative 1, 0, 1. So this is going to be 3, 0, negative 3, 0, positive 3. So we put them in here. 1, 2, 3. There's 3. And 1, 2, 3. There's negative 3. And we start at 3. Start at 3, down to 0, down to negative 3, back to 0, and up to positive 3. And we do our best to get a graph in there. Okay, I missed that one point, but the idea is there. Okay, notice again, everything's the same, everything's the same. There's a lot of little math going on, but all of the math is the same from one to the next. Okay, next one. A equals negative 2/3. This is where I remind you the amplitude is just 2/3, because on the test it will say, what is the amplitude? And you have to know it's the absolute value of A. B equals 3/4. So the period is going to be 2 pi divided by B. So 2 pi over 1 divided by 3 over 4. Multiply by reciprocal. Those cancel out, and we're left with 8 pi over 3. Okay. Our C value is equal to 1, and our D value is equal to 0. So there is no phase shift here. So no phase shift. By the way, on the test, it does ask about phase shift as well. Okay, because there's no phase shift, we really don't need to do these zeros less than 3/4, blah, 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 because we've actually already done that. Our endpoint is at 8 pi over 3. No phase shift means we're starting at 0. And I'm going to bring this 8 pi over 3 all the way over here to the arrow. So 8 pi over 3, which gives me a halfway point, half of 8, 4 pi over 3. I don't care what it is in degrees. Why do extra work? Quarter point, quarter point. But it asks for a 2-period interval. So I need to come over here to negative 8 pi over 3. Again, halfway point, half of 8, 4 pi over 3. Yes, it's negative. And 2 quarter points. Don't forget, zeros in there as well. So then we need to do A times the pattern plus whatever our C value is. So we have 1 times the pattern of, whoops, A is not 1. So let's try that one again. Negative 2/3 times pattern for sine, 0, 1, 0, negative 1, 0, plus 1. Now you can do all of this math at once. I'm going to go ahead and do that. Negative 2/3 times 0 is 0, plus 1 will give me 1/3. Negative 2/3 times, okay, let me go back, rewind. I wish I could do a rewind noise. Let's try that again. Negative 2/3 times 0 is 0. 0 plus 1 is 1. Negative 2/3 times 1 is negative 2/3. Negative 2/3 plus 1 is 1/3. Negative 2/3 times 0 is 0 plus 1 is 1. Negative 2/3 times negative 1 gives me positive 2/3 plus 1 gives me 1 2/3 or 5/3. And 0 again is going to give me 1. Notice that all of your zeros just turned into your C value. So I'm all going to be always positive on these ones, because of that plus 1. So because I have thirds, I'm going to do 1, 2, 3, there's 1, 4, 5, and 6, there's 2. So I'm starting at 1. I'm going to throw this in there. This might help some of you. It may or may not. But this line here that I'm making is actually your new 0. So if you're used to going up and down to 1, this actually will work, because instead of going up and down to, going up and down from 0, 0, negative 1, back to 0, positive 1, back to 0 kind of thing, that what you can do instead is identify the fact that you're moving the whole graph up 1. So now this is your new 0, and all you have to do is the 2/3 part. So we're starting at 1. Make sure I got my pen back. So we're here, 1, down to 1/3, which is here, back to 1, up to 5/3, back to 1, to 1/3, back to 1, up to 5/3, back to 1. Over here. And we can draw our graph in here, and we see that we have the same looking graph, and because we shifted it up 1, that new dotted line becomes my new 0 line, and we have the same kind of graph going on. And so we can, in retrospect, go, well, if I didn't shift it up, all I'd have to do is move these guys down 1. Absolutely. You would move it all down where the dotted line is equal to 0. Okay, I believe we got one more example in here. I think this is the last one. So A equals -3, B equals 1, so our period is 2 pi, or 360. Our C value is 4, and our D value is pi, or 180 degrees. Because we do have a phase shift, so we got to look at our phase shift. So we get 0 is less than or equal to x minus, I'm going to go ahead and throw in the 180, 180, less than or equal to 360. This would have been okay with the pi thing. Add 180, add 180, add 180. So we have 180 is less than or equal to x, which is less than or equal to 540. So if I change this back to radians, this would be pi is less than or equal to x, which is less than or equal to 3 pi. Now, keep in mind, you do have to do your graph up here in radians. I do not want to see it in degrees. You can do your math in radians or in degrees, but you got to go back to radians. So since I'm going from pi to 3 pi, remember before it was pi over 2, I'm going to just do pi's this time. So this is 1 pi. There's 2 pi. And there's 3 pi. 2 pi is my halfway point, quarter point, quarter point. Okay, and then I have the A times my pattern plus C. So in this case, it's going to be -3 times the cosine pattern of 1, 0, -1, 0, 1, plus 4. So we got a lot going on this one. So -3 times 1 is -3 plus 4 will give me 1. 0 plus 4 is 4. -3 and -1 is +3 plus 4 is 7. 0 plus 4 is 4. And -3 times 1, -3 plus 4 is 1 again. So those are the points that we're going to graph on these. So I need to put my points here. And I'm going all the way up to 7. So 1, 2, 3, 4, 5, 6, and 7. I'm going to go ahead and draw that dotted line in at 4. Because if nothing else, if you think of this being your new 0, you're just going up and down 3. So at pi, I should be at 1. And then I'm going to go up to 4. Then up to 7. Back to 4. And then to 1. The graph was turned upside down because the A value is negative. A value is negative, but our amplitude is not. Our amplitude is +3. And there's our graph. Okay, so if you watch this one, you watch just additional examples, which I'm going to highly suggest to you guys anyways. And then again, there is the homework. Hope you guys got this down and things work out well for you.